Today's lesson is Unit 5, Lesson 1, Investigation 2, or Investigation 1, sorry. It's what is a function. So today we're going to learn what a function is. To get us started, we're going to talk about these four graphs. Okay? Really, James? All right. We're going to talk about these four graphs, A, B, C, and D. The graphs are in blue. Okay, you don't need to draw them. We're just going to talk about them, so don't worry about drawing them. All right. So looking at these graphs, I want to make predictions about what a function is and what a function isn't. So looking at these ones, who thinks A is a function? Raise your hand if you think A is a function. Yes, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Wow, 15. 15 people voted. That's fun. So 15. Who thinks B is a function? Normal parabola. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Who thinks C is a function? 1, 2. 2. 3. We'll count Damien's hands twice, so 3. Okay. Who thinks D is a function? 1, 2, 3, 4. Putting up legs too. 5. 5. Okay. So A and B, why do you think those are functions? Because you've seen them before? Yeah. You guys are familiar with these ones? Right? Can they go across the grass like we're used to, right? Have you seen something like C before?
No.
No. So a little unfamiliar with that, right? What about D? No, a little unfamiliar, right? So could these two be functions even though you haven't seen them before?
Yeah.
They could be, right? But we were more comfortable with these ones, weren't we? Okay. All right. Well, let's figure out what a function is, and then hopefully we can answer that question, what is a function? Okay. A function is a rule that assigns one or only one output to every input. So a function is a rule that assigns only one output to every input. Okay? We'll underline this only one. Okay, that's the main part. Only one output to every input. In my mathematical career, it has served me well to memorize that definition. Okay? So if you're going to go on to study math in college, this is something that I would memorize. Okay? If you're going to take one math class in college, which most of you will have to, this is something that I would memorize. Okay? It'll help you out if you can identify functions quickly. Because a lot of what you do in your undergrad or in your first couple math classes is dealing with functions. Okay? Saves you some time if you can tell it's a function or not. Now, inputs. A lot of times functions are represented with equations. When we have an equation, what's our input? What's usually our input? In any equation, what do you usually plug in for? Was it Monica? You plug in for both or just one? Which one do you plug in for? No. X. Whenever we're graphing something, we always plug in for X to find the Y, right? Right? So X is what our inputs are. Inputs, those are what you put in, right? So we usually plug in for X. So our inputs are usually our X values, okay, or the independent variable. Okay. The X values are the independent variable. Those are our inputs. Okay. There's also something about the inputs called the domain. Have we heard of domain before? Yeah, Mark, what's the domain? You heard it before? Okay.
Isn't it something in science?
Well, give me in science. Okay, that's all right. The domain, guys, is all the inputs. Okay? The domain is all the inputs. So I'm talking about the domain of a function. That means everything that we plug in to the function. All the inputs we put in, that's our domain. If our x values are the inputs, oh, go ahead me. What's the outputs? Y values. Nice job. So the outputs are the Y values. And the Y values are what variable? Dependent. Good. The dependent variable. And instead of a domain for y's, we call it the, anybody know? Range. And we talked about that last time. We were talking about the range of a cluster, right? Right? Kind of same idea. The range is all the outputs. Okay. So remember, inputs are what you put in. Outputs are what you get out. Okay? So inputs are x's, that's what we plug in. Outputs are y, that's what we get out. Okay. So using this definition, a function is a rule that assigns one output, only one output, to every input. What does that mean in terms of x and y? Only one output. That means only one what? Nope. Only one output. What are our outputs? Y's. So this means only one y for every x. Or we can say each x has only one y. So we can rewrite this rule to say each x has only one y. Okay? Each x has only one y. If you can't memorize this, memorize that part. A function makes sure each x has only one y. All right? This is the same definition, isn't it? Just paraphrased. So each x has only one y. So, looking back at these graphs, how can we tell it's a function or not? How can we tell it's a function? Nope. That'd be an x-intercept, right? Nice try, though. Okay. What only has one y? What, Matt? Each x. Each x has only one y, right? So, is that an x value? How many y's does it have? One. It's right there, right? Is this an x value? How many y's? One. Right, what about right here? One y, right? Right here, x-intercept, that has one y, doesn't it? How about right here?
No.
Yeah.
Yeah, just below it now, right? All those x's have only one y, right? Is there any x along the x-axis that has only one y? All of them have only one y, right? There's none of them that have more than one y, are there?
No.
What about right here? This x has one y, right? There it is. This x, how many y's does it have? One, it's below it, right? What about this x? One. What about this x? So are these both functions? Yeah. So yes, these two are functions. Okay. What about this one? If I put an x right here, one y, two y's, three y's, right? Is that a function? Oh. Too many y's, right? Each x only gets one, right? Now if I look at the x right here, that has one y, right? So if I just look at one x value, then I might not get the right answer. I got to look at multiple x values, right? So each x should have only one y. This one has three as well, right? So is that a function? No. About this one? James, is that you?
What?
Who said yes?
John.
John, you think yes? Why? Okay, I only got drew it close enough. But that x will only have one y all the way down here, won't it? Right? What about this x? How many y's? One. What about this one? One. This one has one. What about this one? One. What about that one? 1. About this one? 1. About this one? 1. Each x has only one y, right? So is this a function? Yes. Okay. Now there's an easy way to tell if a graph is a function. And it involves drawing these kind of lines, the ones that are green. What type of lines are these?
Vertical.
Vertical. Okay. A special test for determining if something's a function is a vertical line test. You take anything that's straight. Okay. Ruler works great. Your pencil works great. Okay. You start here on the left or on the right, doesn't matter. Okay. Start on the left and we move this way and we make sure that my vertical line intersects it how many times? Once. Because it's showing me that each x only has one y. So this one passed the vertical line test, only hits once. This one, does the graph ever hit more than once? No, so it passed the vertical line test. Right? This one, does the graph ever hit more than once? No, so it passed the vertical line test, right? What about this one? Once I get to here, I should go ding, 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 ding. Doesn't pass, does it? How many times does it hit it? 3 times, right? So it's not a vertical line. Okay? Or, sorry, not a vertical line. It's not a function. It doesn't pass the vertical line test. Right? Does that make sense? Yeah. Okay, so let's kind of put a little more formal definition to the vertical line test. For those of you at home, you might want to zoom in. Okay. Vertical line test. gotta make it fun sometimes. Vertical line test. The vertical line test. Where are my notes? All right. The vertical line test is. Where are they? I know I'm slacking. I gotta memorize everything now, don't I? Okay, that's right. Vertical line test. What this tells us: if a graph intersects a vertical line more than, how many times? Once. It is not a function. So if a graph intersects a vertical line more than once, it is not a function. Found it. Okay, why does this work? Why does this work? Why does the vertical line test work? Shows that each x has how many y's? 1. Okay. This shows that each x has only 1 y. Shows that each x has only 1 y. Are there any questions about functions or vertical line tests? Any questions? Kind of bad, yeah. All right. Any questions? None? Okay. Those of you that voted got them right, great job over there. Okay. All right. So functions. We know what a function is. The rule that assigns only 1 y to every x. Right? So what are we going to use this for now? What do you guys think? What are we going to use this for? Okay, we're going to look at functions. Okay. If I'm going to make a graph, what do I need?
An equation.
An equation, right? If I'm going to make those graphs we looked at earlier on our calculator, I need the equation for them, don't I? So we need to learn what the function rules are, or what function notation is. So function notation. This is an example of function notation. Okay. Whenever I have F like this, see how the F's kind of squiggly? It's like it's in italics, right? It's like I told my hand to write in italics. Okay? Whenever you see the italic F in front of a parentheses with X in it, this means F of X, or a function of X. Yep. Okay. F of X means, or like that when it says F like that means F of X. This is not multiplication. Okay? It is not multiplication. It just means F of X. Okay, it's just a notation. Instead of saying Y, instead of putting Y right here, it's saying function of X. Okay? They're just putting this in for Y, just another way of writing Y. Okay? Now in here, what are my inputs, guys? X's, right? So X are my inputs. Okay? X are my inputs. So if I want to figure out what F of X is for a certain number, we plug that number in for X. So if I want to figure out what this function equals when X is 5, we plug in 5 for X. Okay? Yes, sir?
So we're not actually putting a number in for F.
Not yet. We'll get there. Okay? We'll get there in a second. Okay. Now, how do I find my outputs? We plug the number in here for X, and that'll give me my output. So 3X plus 5, that gives us the output. Okay. 3X plus 5 gives us the output. So 3X plus 5 gives us the output. For example, if I write F of 5, what does that mean? Function of 5 means I'm putting 5 in for what?
Y.
Nope.
X.
X. This means that 5 is my input. So how do I find my output then? I take 5 and I put in this equation for what? X. Okay, is that something we can do?
Yes.
Yeah. So this means we do this. F of 5 equals 3 times 5 plus 5. What's 3 times 5?
15.
15, right? 15 plus 5 is 20. So that means when I plug in 5, what do we get? When we plug in 5, what do we get? 20. So when our input is 5, our output is 20. When our input is 5, our output is 20. Does that make sense? Aaron, does that make sense?
Yeah.
Okay. So another way they can use this function notation is they can write F of X equals 10. What does that mean? Is the input 10 or the output 10?
Output is 10.
Output is 10. Okay? That means the output is 10. So if the output is 10, can we find our X? Can we find our X in this case? No?
Yeah, we can.
Yeah, what do we gotta use, Davion? Use that A word again. What's that A word? Algebra. Okay?
Put a 2 right.
So, from up here, I know that F of X equals 3X plus 5, right? Right? So we have 3X plus 5 equals 10. Can we solve that for X? Can we solve that for X, guys?
Yeah.
Yeah, what do I do first, Rock?
What?
What do I do first?
Subtract
Subtract.
3.
No, 5. Subtract the 5. Right? So 10 minus 5 is?
5.
5. So we have 3x equals 5. What do I do now?
Divide.
Divide by
3.
3. So we get x equals 5/3, which is also 1.6 repeating, right? So what does that tell us?
What your input is.
What our input is, good. So when my output was 10, my input was 5/3, right? And I could go back and plug in 5/3 for x and get 10. Right? Does that make sense? In a moment, we're going to look at page 327 and page 328 in your book to look at a table involving inputs and outputs. Okay, that's how we can try. We can try together. So, finish copying that down, and then we'll look at that page 327 at the table. So, if you're done copying it down, take out your books. Look at page 327, number 1.
Well, that's Brian. That's function.
Where in the board? There you face. Yeah. All right, so page 327, number 1. Okay, on page 327, number 1. Actually, page 327 starts out with investigation 1, and then the actual problem number 1 is on the next page. It says the graph and table below show the dependence of runtime y on the vertical drop x in a luge run. For each x value, there's exactly one corresponding value for y. Sounds like a function. In such case, we say that y is a function of x, or that the relationship between runtime y and vertical drop x is a function. Okay. Now, number 1 is on the next page, on page 328. They have some more information about functions that you can read through on your own if you'd like. All right, but number 1, use the information on the table and graph relating downhill run times to vertical drop on the luge course to answer the following questions in each case. Explain what the answer in the question tells about the luge run variables. I wrote the table up here if you don't have your book. Okay. For number 1a, it says, how is the fact that f of 50 equals 64 shown on the graph? How is that shown on the graph, guys? F of 50 equals 64. What's f of 50? What's 50?
It's the input.
It's the input, right? What's 64? Output, right? How's that shown on our graph? Go back to the next page. On our graph, when you look at the x value of 50, what's the y value? Ooh, look at that. It should be about 64, right? I know it's not a great graph for that, but if you have an x value of 50, then the y value should be 64. Okay? Now the next one, 1b says, what value of y satisfies the equation y equals f of 40? Okay? So, f of 40, right? What is that saying? 40 is my what?
Input.
Saying 40 is our input, right? So if 40 is our input, what's my output? How'd you get that, Trey? Okay, so in our table, we look at vertical drop of 40, then our runtime is 71. Okay, does that make sense?
No.
No?
Because I don't get, like, when I read it, it's just the questions are just...
F of 40, so f of 40 like this, that means 40 is our input. So 71 is the output. Okay, the reason the way I find that. All right,
Okay, I get it.
you get it now?
Yeah.
Okay, we look in our table for where 40 is. Right, so here's 40, and then we know the runtime is 71. Okay, so f of 40 equals 71. The next one says f of x equals 51, right? What are they asking for in this case? The input or the output? You read the first time. Input. They're asking for our input, right? F of x equals 51. This is saying my output is 51. So what's my input? Right? So we found an output of 51 in our table, and we see the input is 80. So this means x equals 80. Okay? Try those next two on your own. Okay, try those next two on your own.